Um, double check though if this is recorded.
Ay, wait,
Sagwan.
wait. Murag wala pa. Ay, na. Yes,
Yes,
yes, na.
recorded.
Yes, yes. Thank you, thank you. I was I was in trance for a moment there. I'm sorry. Let us continue. So, we will be putting the number of atoms of an element on the on the right side of the list, specifically for the product of the equation, the chemical equation. Now, the next step that we will be imposing is to determine the coefficients in order to try and balance the chemical equation. So, as a disclaimer, you can there is you can like add one, two, three on coefficients. There is no set number of coefficients that will be added to the chemical equation. It depends on whether you achieve the balance equation or not. So it depends. So like you cannot say, oh, I can only there is no convention that says you can only put two coefficient in order to balance the equation, and there is no convention that says you can only put one in order to balance the equation. There's no such thing. So this is a process of inspection and like a trial and error. So you need to do the process again and again in order to like solve or like to balance the chemical equation, and a matter of patience is needed. Yeah. So we have two atoms of chlorine. On the reactant side, we have two atoms of chlorine and one for sodium and one for bromine. I think I have here a laser pointer. Here, reactant side, we have, yeah. And for the product side, we have um, two atoms of bromine here, and um, we have one atom. Um, yeah, we have one atom here. But after we added the coefficient 2, it became 2 times, there is an invisible 1 here, one subscript here in every element. So we have, supposedly we only have one atom for sodium here and the reactant side, but because we added 2, on the left side of the formula, it became 2 times 1 is equal to 2. And the same goes with the chlorine. So is it balanced? Of course not. It's not yet balanced. We have um, the chlorine element is balanced, the sodium element is not balanced, and the bromine element is not balanced. So in short, it's not balanced. So we need to add another coefficient in order to balance the chemical equation. Now here, we added the coefficient 2 on the reactant side, specifically on the compound, on the left side of the compound, sodium bromide. So by this, the process before this was retained, uh, only the process in the sodium bromide will be changed. Kanang, we have the same concept. We have one here and one here in the sodium and bromide, but we multiplied two times one for the sodium on the reactant side is it yielded to two atoms, and then same with the bromide. Now, after putting coefficient and multiplying it to the subscript one and or subscript n, for example, like we came up with chlorine having um, on the reactant side we have chlorine two atoms, and because we added chlorine coefficient here on the chlorine, it became 2, so it's balanced, the chlorine is balanced, so check. The second one, the second element is the sodium. So we, because we added 2, we have here the 2, and same with bromine, 2, and that is 2 equal, and and the both of the, all the three of them are like they're balanced. We have 2, 2, and 2, and 2 and 2. So they're balanced. So this is the balanced chemical equation that we did in with the unbalanced equation earlier. Yes. Another example. This is supposedly an exercise, a simple exercise the for the students, for the tutees, but yeah. Who can tell me what is the balanced equation of this unbalanced equation in 30 seconds? All can participate, please, by inspection and everything. You
Guys,
can
you
turn
are really encouraged to participate now.
you can turn your mic on and um, state your surname in order to be recognized. Taker, please. So since there are no takers, I will be the one to answer the question. So the balanced chemical equation of the unbalanced chemical equation earlier is um, 4 molecules of aluminum plus 3 molecules of dioxide yields to two molecules of aluminum oxide. This is done. This is balanced through the process that we did earlier. The same process was implemented in order to balance this one. No, by adding 4 here on the aluminum, it resulted to 4, and by adding a coefficient 3 here, and with the um, subscript here 2, and we will multiply that. So 3 times 2 is 6, and same goes with the product side. We have here, um, by adding 2, we came up with 4 molecules of aluminum and 6 molecules of oxygen. So it's balanced now. Now, in order for you to be reminded of the conventions and the rule of balancing chemical equation, we have here again the rules. Now, moving on to the second subtopic that we will be discussing this afternoon, we have on my discussion we have um, balancing redox equation in both acidic and basic solution. Um, Now, we will be providing you, in order to balance a redox equation in both acidic and basic, we need to follow process in steps. Now, the first one is we need to divide the reaction into half reactions. The second one is we need to balance the elements other than H and O, and we need to balance the oxygen atoms by adding water H2O, and we need to balance the hydrogen atoms by adding H plus, and this one has charge now, and balance the charges by adding electron, and to come up with the balanced chemical equation, we need to add the half reactions and simplify. Now consider the following unbalanced redox redox reaction rather. We have we have here um, MnO4 minus, which is in aqueous solution, and zinc, solid zinc yields to um, MnO2, which is solid, plus the ZnOH4 2 minus, and that is in aqueous solution. Let's try to balance this acidic solution using the steps that I stated earlier. Now, the first one is we need to divide the reaction into two half reactions. So by dividing the chemical equation, we need to consider the elements that they must be they must be the same elements on the reactant and the product side. So for the MnO4 MnO4 minus on the reactant side, we have this is the first half reaction that we are dealing with, yields to MnO2. And the second half reaction we have is the zinc yields to ZnOH4 2 minus. That is the very first step. The second step is we need to balance the elements other than HO. So the elements other than HO here is the manganese and the zinc. Both of them are, of course, obviously not H and O. So, but by inspection, we can tell that they are already balanced. Fortunately, all atoms other than H and O are already balanced. So we can move on to the next step. But there are instances that they are not the elements other than the H and O are not balanced. So we need to implement these steps that I gave earlier to balance the non H and O elements. Now, the third step is we need to balance the oxygen atoms by adding H2O. So we have here um, four oxygen atoms on the reactant side on the first half reaction, and we have here two um, we have here two oxygen atom on the product side. So by adding H2O, we need by adding H2O. At first, before I forget, first you need to total the if there are more than two formulas here on the kanang on the both products and reactants, you need to add the oxygen uh, in order to balance it properly. So we have here 4 and 2, but adding H2O, by adding one H2O alone will not yield to balance oxygen atoms. So if we will only add H2O here, so the the oxygen will only be 3. 2 here plus 1 here is only 3, so they're not balanced. So we need to put a coefficient on the left side of the H2O in order um, to balance it, and that is the coefficient 2. So by multiplying, we have 2 times 1, so that's 2, plus 2 here, so it's 4, and yeah, it's balanced already, the oxygen atom. So the next one, the same step must be implemented for the next half reaction, the second half reaction. So we have here, this is a bit tricky. Most of the students, or like I guess most of the students will be confused because the OH was put in a parenthesis and kanang naay subscript sa gawas. So like you need to distribute the subscript to both the oxygen and the hydrogen. Now remember that. Now, originally there is no oxygen atom on the reactant side and only in the product side. So that is much easier. So by multiplying 4, by distributing 4 to the O, oxygen here, we have 4 oxygen atoms. And in order to, by adding, the step is add H2O in order to balance the oxygen atom. So we will put 4 H2O here because only by adding one molecule of water is not enough. So we have here 4 and we have here 4 on both sides. That makes the second half second half reaction a balanced one. The next step is we need to balance the hydrogen atom. So earlier on the previous on the previous step, we balanced the oxygen by adding H2O. Now we need to balance the hydrogen atoms by adding H plus. So here, originally there is no H plus here, only here in the product side because we added H2O. So there is 2 times 2, there will be 4 hydrogen atom on the product side. So in order to balance that, we need to add 4 H plus on the product side. So 4 and 4, they are balanced. Here we have 2 times 4 is 8. We have 8 hydrogen atom on the product side of the second half reaction. And we only have H and like 4 distributing hydrogen. We have only 4 hydrogen atom on the kanang product side. So we will add 4H plus also. And 8 and 8, they are already balanced. So the next step is we need to balance charges by adding electron. Now, on the on our half reactions, we have here the negative. Please, like you need to take note of these negative, positive, yeah, on the as on the upper side of the formula. Those are the charges of compound or the elements. So we have here on the MnO4 minus, we have negative 1 in here. And because we added 4H plus here, we have 4, we have 4 positive 4 charge in here. And we don't have charges on, this is 0 and this is 0. There is no charge in here. So in order to balance that, we need to add 3 electrons in here because 1 plus a negative 1 plus 4 charge here is equal to positive 3. So in order to balance that, we need to add 3 electrons. So that is positive 3 plus negative 3 is equal to 0. The same here, the same happens with the second half reaction. There is no charge here. Take note, there is no charge here. That's 0, 0, 0, 0. And in ZnOH4, we have 2 minus, so this is 2. The charge here is negative 2. Plus, we have 4, we have we have 1 here, which is 4. That is positive 4. The charge here is positive, plus 4. So negative 4 and plus 4, if you simplify that, it will yield to plus 2 charge. And yeah, we will add kanang 2 electrons in here in order to balance that. Now, add the half reactions and simplify. Yeah. Um, the purpose of this step is to eliminate the electrons on the half reactions. So because we have an equal here, an equal number of electrons on the reactant and product side, we need to like multiply them to a specific number in order to make them equal. So by multiplying 2 to the 3 electrons here on the reactant side, and by multiplying 3 on the 2 electrons here on the product side, it will yield to this one. Carrying this out, we get, yeah, so we will be canceling this one. Yeah, this one is will be canceled because they are on the left side of the arrows. And you will not only take note that you will not only be multiplying the electrons, the 3 electrons here. You need to multiply the entire thing. Now we can add the 2 reactions and notice that the electrons on both sides are canceled out. You have canceled out here. And also, if there are like similar or like in mathematics, it's like terms here in the on both sides of the equation, you can cancel that out, or you can um, perform an operation. For example, we have 12 hydrogen, 12 H2O here, and we have 4 H2O here. We can subtract that, and it will yield to 8 H2Os. And same goes with the H 8 H plus here and 12 H plus here. Now our balanced equation is 2MnO4 minus plus 32. It's 3 zinc, sorry, plus 8 H2O yields to 2MnO2 plus 33 zinc 3 ZnOH4 2 negative plus 4H plus. There is another example, but I think we are short of time now. So this will be an exercise for you. You can either, it's up to you if you will solve this or not. But in order to learn, I encourage you to please solve this. Now that was Yeah, here we have the solution here. Now, the first one was that was the balancing redox reaction in basic solution. So the second one is the acidic solution rather. The second one we will be tackling the balancing redox reactions in basic solution. So the processes or the steps in balancing the both acidic and basic solution equations in basic solution, they are somewhat overlapping, but in the basic solution there are additional steps. That is, after implementing steps 1, 2, 3, and 4, you need to add OH minus ions to both sides to neutralize the H plus, and combine H plus and OH minus to make H2O, and simplify by canceling out excess H2O, and continue with the process. So you will know later why we need to neutralize the H plus on the, yeah, on the equation. So the same example is given. So here, yeah, we were able to divide this into two half reactions earlier, and yeah, the elements other than H and O are all balanced already, and balance the O atoms by adding, yes, we did this earlier, and balance the H atoms by adding H plus. No, the additional input that I will be telling you in order to balance the basic solution, in order to balance redox reaction that is in basic solution, is the step 5. We will start with the step 5. So by balancing H atoms by adding H plus, it yielded to H plus, there are H plus in the chemical equation now. So in order, we need to neutralize this H plus and by adding OH minus. So like in here on the reactant side of the first half reaction, we have 4 OH plus. So we need to add 4 OH minus in order for this to be neutralized. Neutralized meaning like zero. Um, there is no excess, and there is no lack something. And on both side, please take note that in neutralizing H plus, you will not only add 4OH on the side where there is H plus, but you need to add OH minus on both sides, the reactants and the product. Now we have here 4H plus, so we need to add 4OH minus, and same by adding both sides, yes. And the sixth step is we need to combine H plus and OH minus to make H2O. This is also an additional step. So we have here 4H plus plus 4OH minus. It yielded to 4 molecules of water. Same goes with here. And then, yeah, the same. It is stated na here. Now, the third additional step to balance the redox reaction in basic solution is to simplify the equation by canceling out excess H2O. So we have here 4H2O, and we have here 2H2O on the product side. So we need to simplify that because we can perform an operation to cancel that out. We need doing the operation, it yielded to 2 molecules of H2O. And take note also that we have 4H2O here, and we have 4H2O here. So they are canceled out because 4 minus 4 is 0. Now, after implementing the additional 3 steps, we will continue with balancing. Now, we need to balance the charges by adding E. Yes, we added earlier 3 electrons on the reactant side of the first half reaction, and 2 electrons on the product of the second half reaction. And by multiplying in order to cancel the excess E, the electrons the same. Yeah, so the kanang the if this chemical equation is in basic solution, the balanced chemical equation will be this one. Our final balanced chemical equation is this one. So yes, this is our balanced equation. And I have I have ano here sana. But yeah, the reason why neutralize we need to neutralize the hydroxide, which is the H plus earlier, is because basic solution must be in base catalyzed reaction. So there should not be any H plus because that only happens in acidic solution. So I will reiterate. So we need to neutralize the H plus on the chemical reaction because this is in basic solution, and basic solution must have base catalyzed reaction. And for the reaction to occur, the solution must be in basic and hydroxide as hydroxide is had must be basic and hydroxide is consumed. Yeah, because it is in like acidic. It's just it is just regenerated in the exact same amount, so it cancels out in the final answer. Yes. So we have here a little tip in order to balance the chemical reactions. The first one is to write the unbalanced equation to show the reactants and products. So you need to be able to separate the formulas using the plus sign and separate the kanang reactants and product side using the arrow sign. And write down how many atoms of each element there are on each side of the reaction arrow. And add coefficients, the number in front of the formula, so that the number of atoms of each element is the same on both sides of the equation. That is in fulfillment to the law of conservation of matter. And do not be complacent after yeah, yes, you saw that there are the equation is balanced already. Do not be complacent because there might be something wrong with your work. So in order to kanang arrive at a perfect na work, you need to check your work, if not one, two times. Yay, smile, fighting. Thank you for listening, and I hope you will have a great time on the upcoming kanang midterm exam and your kanang mga future pa na mga assessments. That is the end of my part, and I really hope that you've got something, and um, yeah, thank you. I will end the first
Thank
speech.
you, Mr. Gallego. Am I audible?
Yes.
Okay. Now I guess it's my turn. I'm going to have to share my screen. Congrats, Joel. Thank you. A job well done. Now it's my turn. Okay. Can you see my screen?
Yes po.
Yes.
Okay. I'm sorry for our dog, huh? Okay, so can you screen? All right. So that was balancing equations by Mr. Roel Gallego. Unfortunately, Miss Ina Gofan is am I correct? Unable to fan. So for this topic, we're going to talk about redox reactions. So I guess you're familiar with this guys already, with this topic already. but we're going to consider others now. We don't have the same paces of learning, so might as well review and get back to basic. Am I right? This is for first years, no?
Yes, ate.
Okay, okay. Namagay ubang nga first years they have surveyed thermodynamics, and I suppose that would be on second year, perhaps, supposedly. And I don't know. Wala
Nasa
na namo
year, ate.
nasa may kuan thermodynamics.
Oh,
Hmm.
nasa.
Okay, okay. Warag lahi po dito nga kuan. Okay, let's start. So ready na mo? Can I see some reactions? If you are guys ready? Okay, very good. Nakram lagi. Okay, now let's help each other learn. No, if I have something wrong, if na ko natabi nga sa'yo, please let me know, no? Because I might get out of track and bisag unsa na ako matabi. So, our objectives for today is to determine the oxidation numbers, oxidizing agents and reducing agents, and how to balance redox equations. Okay. So, introduction. Now, introduction for redox equations it is basically oxidation reduction reactions. So, redox reactions. Now, in this process, electrons move between atoms. Now, like this one. It can also be atoms. So it can also be compounds where it transfers electrons to other compounds or atoms. Now, please keep in mind that reduction is the gain of electrons and oxidation is the loss of electrons. You might be confused now why reduction is the gain of electrons. Now, it's supposedly if reductions kay it has something less of it no magamyan sa if reduction and oxidation. Now, but in this topic, no, I will explain to you why that is the meaning of reduction, gain of electrons. Okay, now in this figure, atom A, let's just say atom A is giving electron to atom B. Well, this might be familiar for you guys now because I also see YouTube and it's very good medium for you guys. If supposedly dili mo makasabot sa modules sa inyong profs. If you want much simpler terms, then YouTube is a good medium. So now in this in this figure, no, atom A is giving electron to atom B. Now in this case, atom A is losing electrons, so this is oxidation process occurs. Now and atom B receives electrons. Now that the process is called reduction. Simple, atom A is oxidized and atom B is reduced. Now, please always bear in mind that oxidation and reduction always happen at the same time because once there is something gained, there should be something that loses, no? And they should happen at the same time. They cannot be, that is not possible that they are in a different world. They should be happening at the same time. Now, this is the reason why reduction is the gain of electrons. Now, can you see this figure? What have you observed? Hello? Wala? Okay, I understand. Now, in this figure could explain to you know why reduction is the gain of electrons. Now, as you can see in this figure, as you add electrons, the charges reduces. And remember how when we write reduction, oxidation for reduction, the sign is minus and oxidation is yes, plus. Loss of electrons is plus and reduction, the gain of electrons is minus. And that would really somehow confuse you guys, especially if you are in developing in progress of learning the subject. Okay, so this would be a good example. Now, as you add electrons, the charges are gone. As electrons are gained, the charges reduces. You can see in this figure. That is the reason why. Now, do you know what our oxidation number is? This one. These are the positive or negative numbers indicating the amount of oxidation or reduction in atom. Okay, this is what I mean by that. So I guess this is the oxidation number, the one that I've encircled. The +3, +1, those are the oxidation numbers. Now we will go along. You might as well save this picture, because this is really helpful upon determining oxidation numbers. Okay, first, an element by itself. These are the rules for calculating oxidation numbers. Now, an element by itself, its oxidation number is 0. Now, here's what I mean by that. This one. Chlorine, sodium, sulfur, phosphorus, they are basically by itself. They're not combining with any other element. No, that's why their their oxidation numbers are 0. They're not combining with any other, just by itself. And now, the monoatomic eigencharges. This one. As you can see, the oxidation numbers, these are the red ones. And as you can see, it is written opposite of ionic charges. In oxidation numbers, we write first the symbol, then after the integer, +1 or -3, +2. Then ionic charges, mag-una ang numbers. Like here, 3 minus and 2 plus. Please be cautious of that. Okay. Let's try some examples. Na-master na ninyo ang oxidation numbers? I have the notes with me, no? Hindi ko magpatakagawit na gawin. Masayop ko. Okay. Let's try some examples of oxidation numbers. I'll give the first example. MgO. So, ato na ibalik sa ako anli. Ang MgO sa atong table, look. Yan. Ang Mg it belongs to 2A. Here, this one. You can see my pointers. Now, it belongs to 2A. This is very helpful. And in 2A, the rule is always +2. The rule is always +2 ang group 2A. Now the oxygen, it says here that oxygen is usually -2. Usual yun na siya. Pero -1 na siya if it is in peroxide, but definitely it is not with peroxide, it is with magnesium. So we will write that -2. That's it, that's so simple. Next, NH3. Okay, no, it's there. Okay, NH3. So, ang N, we still don't have any information about that on the table, the table that I have shown you. No, and for hydrogen, okay, let's get back. Let's get back on hydrogen. Okay, this one. Hydrogen is +1 with non-metals and -1 with metals. So is nitrogen a non-metal or a metal? Okay, nitrogen is definitely a non-metal. So, ang rule niya, if non-metal, +1 ang H. So, that is the reason why we have this. But take a look at that now. Hydrogen has 3 atoms. That's why we are going to multiply that. Oh, sorry. Wait lang ha. Saan si Lola? Okay. Ano siya? That's why we are going to multiply that by 3 since there are 3 atoms in hydrogen. And after that, since this is a neutral compound, makailaman ka if neutral compound siya if wala sa charge. Like for example, naman siya minus the ari after ano sa H. So this is a neutral compound. No? And the rule for neutral compound, the total number of oxidation should equate to 0. Ano siya? That is why, na naman tayo 3 daan sa hydrogen, we should get that nitrogen should have negative 3 in order for us to have 0 since neutral compound man siya. Number 3, Br, bromine, and oxygen with 3 atoms. Now take a look at this, guys. Check this out. Here's what I mean by ionic polyatomic ion. No? It has a negative charge in it, and it is no longer a neutral compound. Okay. So, saan man siya? So, ang bromine kanila belong sa halogens. And the rules of halogen, they are usually negative 1, but not always. They can be positive with oxygen. Now here he comes, he is paired with oxygen. Now let's go to oxygen first. Since oxygen is usually negative 2, but negative 1 in peroxide now, but it's definitely not peroxide, so we'll have 2 first, negative 2. Since there are 3 atoms, we'll multiply that by 3. We can get negative 6. Now remember, this is a polyatomic ion, which means the total number of oxidation is equal to the charge of the polyatomic charge. There's the ion charge, which is negative 1. So negative 6 plus something, so plus whatever bromine is the value of oxidation number, it should equal to negative 1. So therefore we should have positive 5. Minus 6 is equal to negative 1. Now that coincides with the rule of our halogens, no? That it can be positive with oxygen. Now look at that. That is positive. Next. C, chlorine and Fe. Okay. Take note, guys, that chlorine and fluorine are both halogens. You can see that in the table, in the previous table, that they are both halogens. Now, let's go with fluorine first, because there is one rule for F, and that is always negative 1. So let's go with that first. Negative 1, and it has 3 atoms in it, so times 3. So we have negative 3. And the rules for halogen is that it is usually negative 1, but not always. It can be positive with oxygen, and it could be also positive with another halogen, because there's these times that halogens combine with another halogens. So, and this is not a polyatomic ion. This is a neutral compound. As you can see, it does not have any sign with that. So it should equate to 0. That's it. Now let's go to oxidizing agents and reducing agents. So there is the root word agent. An agent makes something happen. Wala na mga salida ko. an agent makes this very tragic or successful, and that is the agent. It makes something happen. Now in redox equations, we have this oxidizing agents and reducing agents. And that's basically oxidizing agents makes oxidation happen, and reducing agents makes reduction happen. Yeah, that's basic already. Now, look at this. We must always take note that daghan kini flip-flops ang oxidation and reduction. Because the one, bali-bali na po doon. The one being oxidized is the reducing agent, and the one being reduced is the oxidizing agent. Ano siya? Now in this figure, atom A gives its electrons to atom B. Now A loses electrons, so A is oxidized. Because ang lose of electrons kay oxidation ba yan? A is oxidized, and A gives electrons to B. Now atom B makes atom A makes reduction happen. Now A is the reducing agent for that. Basta tanaw lang ninyo kung kasi na-oxidized, mo na'y reducing agent. Ano siya? For B gains electrons, B is reduced. B takes electrons from A, oxidizing it. Oxidized, by giving electrons to B. Now B is the oxidizing agent. Ano siya? Now kani guys, mo ni siya ang as we go along with equations na, because we are dealing with equations already here, to determine the oxidation number, the oxidizing agents and reducing agents. Okay, first equation. Simple pa rin na equation, ha? Simple pa. Magkalagay lang ito niya. Okay. As you can see, zero man na. Can someone tell me why the oxidation number for that is 0?
3 element.
Excuse me?
A single element.
Okay, very good. Because it is just a single element. It is not combining with any other element. Unlike this one. Since iba naman tamo compute sa oxidation number with the past slides, ako na ihatagdaan. Now observe. The calcium, 0 dihadapita in the left side of the equation. But, himo na siya plus 2 diri sa side. Now, ay tamo tanaw na po diyan. Oxidation, the loss of electrons. Again, reduction, gains of electrons. Now, ay mag-base sa oxidation numbers. If they increase gani, oxidation na siya. If they decrease ang oxidation number, reduction na siya. Now, from 0 to 2, obviously, that increase. So, calcium is oxidized because na-increase man ang oxidation number, loss of electrons that was happening. And for this chlorine atom, from 0 to -1, obviously it decreases. So reduction happened. Chlorine is reduced. It gains electrons. Okay, so basically calcium is giving its electrons to chlorine. Ano siya? Sagot na yung equation. Okay, nabalik na putaan ni siya nga reminder. The one being oxidized is the reducing agent, and the one being reduced is the oxidizing agent. Now, asa man ani ang reducing agent? Can someone tell me asa ani ang reducing agent? Based from our figure.
Calcium.
Okay, very good. Calcium is the reducing agent. Basta i-take note ang ginin ninyo ang mga reminders guys. Now, aron dili mo magkalibog-libog kay actually libog to kanay man kay flip-flops daghan kay magbali-bali. And even ako magkalibog ako ko sa mga terms. So better mag-aray mo ani no, but not during exams. No? Every activities you should have to base this one. If it isa pag simple kini siya nga equation ni together. Now that makes chlorine as the oxidizing agent because it is being reduced. Okay. Next. You might be familiar with this one. No? Kailan mag-organic chemistry sa YouTube?
Yes po.
Yes, ate.
Actually, no, that is really a good medium for learning, no? Basic ka ng, in simpler terms, makasabuti ka ba? Now, okay. As you can see, no, the bromine, nakakandi ko na wait. First, look up the sodium. What can you observe about the sodium, the Na? What can you observe about the oxidation number?
Positive 1 because it belonged to group A.
Yes, well, about the left equation, positive 1 gihapon nun, so nothing changes. So there's nothing to worry about that, no? If parihara ang oxidation number. Ang atong problema ko na hindi kaning mga nangausap. Can you look at that? The bromine from -1 to 0, na-increase, decrease. Na-increase, wala mang increase. Yeah. Dayon, if increase, oxidation happen. So bromine is oxidized. It loses electrons. Can increase man yung oxidation number. Now, that makes chlorine from 0 to -1, you decrease. That makes chlorine reduced. It gains electrons. Nana siya ka-simple, guys. Really, simple. Okay. Remember na po the one being oxidized is the reducing agent. And the one being reduced is the oxidizing agent. Okay. Sige, kita naman. So bromine is the reducing agent and oxidized ng siya. That makes chlorine as the oxidizing agent. Okay. This equation na po. Na mga, basta ka na makabantay gay mo nga, dili ra mausap. Okay, there's nothing to worry about that. Ang inyong problema ka yung mga nangausap. Okay, like this one. I guess the hydrogen here is the same. Look at that. In the left equation, positive 1, plus 1, plus 1. On the left side, plus 1 happen. And also the oxygen, negative -2. And on the right side, -2 happen. So there's nothing to worry about that. Arita sa mga nangausap. Nitrogen, look at that. From positive 5 to positive 2. That means, it is being reduced. Decrease man siya. And the sulfur, look at the sulfur from -2 to 0. It increases, no? So sulfur is oxidized. It loses electrons. Now, kanina figure, so that you might as well include the compound no, upon the diagram of giving of electrons. So the sulfur is included in the compound of H2S, so you might as well include that. No? So basically, sulfur is giving electrons to the nitrogen in HNO3. You know, for good practices, you can also include the compound. Ano na punta, balik na punta. The one being oxidized, blah, blah, blah. Ano siya, you must always remember that. Basta nalagyan yung mga guide, digit ng mga wa. Ano siya. Now, this makes H2S as the reducing agent. It allows reduction to happen. And HNO3 is the oxidizing agent. Balik na punta ani. Kani guys, kaya kamo ipa-compute na ko ani. Since kabawa naman mo compute sa oxidation numbers, no? So mag-times, it na atoms. Okay. I-disregard na siya ha, kaya balance naman siya. Upon computing the oxidation number, kaya dili naman siya mag-matter. Okay. I will give you, since oxygen is usually negative dome, unless if it is with peroxide, but definitely it is not peroxide. It is with chlorine, so negative 2 atong oxygen. Now, I want you to compute for the chlorine. And take note that this is a polyatomic ion with a charge of -1. This is not a neutral compound. So, pila may no-equate sa pila may total number of oxidation nga mo-equate sa polyatomic ion? Pila? That is -1 because equal ang ma-equate sa kung pila pod ang ionic charge. -1 naman ang charge and so ma-equate ang -1. So mao ni siya. Since our oxygen is times 2. So we have -4 kay it has 2 atoms na -4. Pila man ang chlorine para mahimong -1 ang equal. +3. +3 minus 4 is equal to -1. Sakto. Now for this chlorine in perchlorate ion, +7, I will look up. -2 for the oxygen times 4 is -8. For us to have -1 for equal sign, we should have +7. The same goes for the disregard the name. It doesn't matter. Unless it will balance that. This is already balanced. Now, -2 for oxygen times 3 is -6. So +5 minus 6 is equal to -1. As you can see, the chlorine in this one is from +3 to +5. It increases, so oxidation happens. Okay, chlorine atom in ClO2 is oxidized. And this one, the chlorine in perchlorate ion, look at this. Chlorine atom in ClO4 is reduced from 7 to 5. It decreases. So basically, chloride ion is the reducing agent. This one. And the perchlorate ion, this one, is the oxidizing agent. Now, can I have Mr. Marami ka na questions about the reducing agents, guys, and oxidizing agents and oxidation number? Do you have something in mind? Okay, if wala, you should go on with balancing of redox reaction. Actually, Mr. Gallego have already explained to you the nature. And kanisha, balancing redox reaction is all about. Actually, natakol na ni Mr. Gallego in his slides, but Mr. Rubio would like to give some few more examples.
So good afternoon, everyone. So as what Lee said, nga natakol na ni Romel Gallego ganina, pero ako lang ikuan balay for the sake nga this is part of the reduction oxidation reaction gihapon ang balancing. So may I ask if kanang daghan ay napabay questions about ganina sa gitakol ni Mr. Gallego? Kanang raise hands lang. Napay questions? Anything? Wala. So, paano ni siya?
Please proceed, Mr. Rubio.
Excuse me? So, review na lang din siya. Siya.
Yes.
So,
Especially sa kapag mga naglibog pa, no? Okay.
next slide, please. So, again, mo ni siya ang steps sa pag-balance sa reactions. So, first, imo sa siya i-separate ang each half reaction. So, per element na imuhang per element nimo ang pagbalance. So, o per reaction sa for in this case, this is carbon dioxide ang sa babaw, ang sa ubos kay this is chromium. Okay, so imo sang gi-divide, so that's C2O4 with a charge of -2. Then ang product is 2CO2 in a gaseous state. Then ang reduction reaction is Cr2O7 with a charge of -2. Ang product kay 2Cr with a +3 charge. Pasensya if saba kayo. So, i-balance na to ang oxygen atoms by adding H2O. So, naman tayo C2O4 here. Then CO2, so balance naman siya kay 2 times O2. So, that's 4. So, mahimo siyang upat ka oxygen atoms, then dire 4. So, okay na siya. Dire na may O7, but in this side, wala gihapon sa 2Cr3. So, mag-add ta og duha ka, ay 7 ka H2O molecules. Okay ra so far? Next, please. Next slide, please. So the third step is to add H plus ions to the missing H atoms. So again, C2O4 with a charge of -2 is already balanced for H, kaya wala man siya H, wala siya hydrogen. Then here, since naman tayo gibutang nga water molecules ganina, so naatay 7 ka water molecules, pero each water molecule has 2 hydrogen atoms. So 7 times 2, so that's 14. So mag-add ta sa pika side of 14 H plus para mabalance ang duha ka side. Next slide, please. So then, imo dayon tan-awon ang charges. So, ang total charge man diri sa left side, sa first nga half reaction is -2, denoted by 2 minus sa superscript babaw sa 4. Mag-add ka og electrons to counteract that charge. So, -2 sa left side, so mag-add ka og basically -2 sa right side, denoted by 2E minus. Then for the other half reaction, so reduction half reaction, the total charge is 12 already. Kay 14 times H plus, that's 14. Okay? So that's 14. 14 times 1, that's 14. Pero -2 man ang pikas, so 14 plus -2 equals +12. Then sa right side, ana niya, sa yung product nga side, na ay 2 times 3 plus, so that's 6. Ang H2O nga part wala siya charge kaya wala siya gibutang nga sign. So imo na siya atbangan, so 6 here, 6 diri plus 6. So imo na siya atbangan og -6. Kaya para mo mahimo sa ni siya og +6 kaya para mag-equal sila +6 sa both sides. Next slide, please. Next slide, please. Then, ato siya i-make sure nga for both half reactions, same ang number of electrons. So, sa oxidation half reaction, na siya 6 electrons na sa product side. Then here, nasa siya 6 electrons sa reduction half reaction nga sa reactant nga side. So, balance na sila. Next. So mo na i-add silang tanan, i-add na dito nimo ang reduction ug oxidation nga half reactions, i-add nimo ang tanang reactant nga side, i-add sa nimo tanang product nga side. Pag human i-cancel tanang like terms, so here ma-cancel nimo ang electrons duha sa each side. So, matangtang ang duha ka electrons and make sure nga wala dyan electrons for the final answer. Then, napay last nga matangtang which is saman. Wala na. So, muna to siya tanan. So, muna na siya itong final answer. 3C2O4, -2, plus Cr2O7, -2, plus 14H plus yields 6CO2 plus 2Cr3 plus 7H2O. So, na questions? Am I audible? Na questions? Please raise lang hand if na questions, please. If wala, let's move on. So magyapon na siya. Same concept gyapon siya sa gitudlo ni Roel Gallego ganina pero kanang kuan na siya. Nang lahi-lahi lang siya term pero same na gyapon to sa gitudlo ni Roel ganina. So next slide please.
So you're giving overview ano? I mean review there.
Oh, basic na lang gid kalit. Wala to siya. Thank you.
Okay. Thank you, Mr. Rubio. Okay, am I audible? I would like to say something. Am I? Okay. Ay, maudi ay. Hindi rin ako gibuta. Oh my God. Okay, as you can see, no, in this slide, okay, there is an indication nga a half reduction and half oxidation. Ano sa ba to? Yes, reduction, half reaction. Because we call that half reaction no, because in one equal equation, naam gina ang oxidation of reduction. So, they are basically gitunga nila ang usa ka complete equation. That is why kanami gina always gina magkuan ang reduction og ang oxidation of reduction. They're basically parting the whole equation. That is why they're called half reactions. So, mo na siya nag-complete sa usa ka kuan. Now, saba na ko ganihan daw, you did not tell me. Nada ka na something saba nga kuan lang. Actually, naguto na ako gitunong sa laptop nga side nga warag fan. So, pardon for that. Okay, now we should have our next kuan, the calorimetry, I guess.
Hello, good afternoon. I will be discussing to you calorimetry. Can you please tell me if my slide is visible?
Yes, yours is visible.
For a second, it's raining. Hello, am I audible enough?
Yes, you are audible.
So I will be talking about calorimetry. Calorimetry is the process of measuring the amount of heat that is either absorbed or released in a chemical reaction. These reactions are classified into endothermic or exothermic. Endo meaning it's taking in heat, as you can remember it by the word endo, in, or exo, releasing heat. You can remember it by the term exit, exo. We use the change in water's temperature to measure the said amount of heat released or absorbed. So to do this, we need to build a calorimeter, which there are two types of. First is a coffee cup calorimeter, or known as constant pressure calorimeter. This is the most basic and common calorimeter that you can make even in your homes. You just need two coffee cups, a thermometer, and a stirrer. The next one is the bomb calorimeter, or known as constant volume calorimeter. This is a bit of a more expensive calorimeter, uh, where materials are not really readily available in your home, such as a large uh, steel container and a smaller stainless steel container, which contains the flammable component. You can call it a bomb inside, with spark plugs to ignite it. There are some formulas to remember about calorimetry. Standard formula for when solving for the calorimetry is Q, which is heat absorbed equals mass times the specific heat capacity times the change in temperature. There are different types of specific heat capacities depending on which material you're using, but commonly used is the specific heat capacity of water, which is 4.184 joules per gram Celsius. There are some examples. How much heat is required to heat 15 grams of water from 20 degrees Celsius to 70? First, you take the given. Mass is 15 grams, temperature initial 20, temperature final 70, and the specific heat of water is 4.184 joules per gram Celsius. And what's asked is the heat source. So we use the standard formula. Remember to always include your uh, units so that when canceling, it won't be dili mo malibog if pag-cancel mo sa units. That amounts to 3,138 joules, or simply 3.14 kilojoules. Example number 2 is 293.7 joules of heat is removed from 5 grams of aluminum, resulting in a temperature drop from 85 degrees Celsius to 19 degrees Celsius. What is the specific heat capacity of aluminum? Heat is removed, so it's negative 293.7. The mass is 5 grams, temperature initial 85, and temperature final 19. And we are looking for the specific heat capacity of aluminum. So we use the standard formula again, but this time we transpose it. So we are looking for the heat capacity. So the formula now is Q divided by mass times delta T. Remember to always keep the units, so when canceling you won't be confused. And the answer is 0.89 joules per gram Celsius. Here are some examples. Why don't you try it yourself? Let's allot 5 minutes for this problem. Just type your answers in the chat. By the way, any questions for solving the the heat absorbed? Okay, has everyone finished answering? Okay, let's solve it together. Albrin Paul C. Senner. Let's see if your answer is correct. So, first, we get the given, which is 500 grams because 500 ml is equal to 1 ml is equal to 1 gram. So that translates to 500 grams. And the specific heat capacity of water, 4.184 joules per gram Celsius. And then delta T, which is 68. So we use the standard formula again. And the heat absorbed by the water is 142,256 joules. Or as Albrin Paul Seno answered, 1.4 times 10 raised to the power of 5 joules, or simply 142. Oh wait. Yeah, you are correct. You are correct, Albrin Paul. Uh, but or simply 142.26 kilojoules. Here's another example. Try to answer it on your own. I'll give another 5 minutes. This requires the transposing of the standard formula.
Kira mo niya, guys. Hello, James. How many examples do you have?
Only two.
Okay.
This is the last example.
Nice, nice. So, guys, you better cooperate, no? It's for your own good, pod.
Asang chat box din sa
Hello, hello, yes.
i-chat ang answer sa
I cannot hear you properly. Can you just type it in the chat box?
ah
Sorry, it's raining quite heavily in my area. I can't really hear that well. Okay, the 5 minutes are up. Seems no one has posted any answer, so let's try to solve this together. So once again, uh, write down. Oops. Once again, write down the given, which is Q is equal to 500 joules this time because heat is added, so it's a positive. Mass is 25 grams. The specific heat capacity of iron is 0.45 joules per gram Celsius. And our initial temperature is 22 degrees. So standard formula, but this time we split the delta T into final temperature minus initial temperature, and then we transpose, we create the equation Q divided by mass times specific heat plus initial temperature. So we substitute the values and we get 66.44 degrees Celsius. Thank you for listening. Do you have any clarifications, wild reactions, or questions regarding calorimetry? Kindly just type in the chat box because I cannot hear clearly because of the rain.
So guys, do you have any questions? Please let us know lang ha. If you don't have any mic, then you can post that on our chat box. Chat box. Sorry. Sapid-sapid na kung dila dre na. Okay, if you don't have questions na, then wait. Amo na ingon gani ha guys, nga saba dai kay akong background. Actually, naputang na ko akong mic dapit sa fan sa laptop, no? Okay. So, please fill up this form, no? The evaluation form. It is for us to know so pwede na mo ma-improve or something, you have comments regarding our session. Okay. Okay, you don't have any questions? All of you are first years here? Or na ay second year ninyo? Okay, I guess there's no questions. So guys, can you please open your camera if that's okay with you? We'll have our photo opportunity. Can you please turn on your your cameras? Can you please turn on? We will have our photo opportunity. Where are you guys?
Ate, oh, nag-sleeveless man.
Ah, okay. At home tayo dito ah. Okay, Mr. Gallego, where are you? Where are you at? I guess na ninyo.
I'm here. Like, kanang, wakay me tubig,
Okay.
so I haven't taken a bath yet.
Uy, same. Hindi ka
Uy,
nag-iisa.
Joy tubig. I'm sorry for my devastating look. Pero thank you bitaw guys for your cooperation, especially kaning we really appreciate kanang inyong mga answers, di mga chat niyo diri sa ano and reactions. So
Yes.
this goes to show that the ME Tech Noise are really kanang welcoming at heart and kanang mo participate jud sa kung unsaang mga ano ano sa situation. So this is our first Metalino tutorial session. So this has been or this is a great opportunity for us to express our service to kanang speech to kanang everybody and kanang this we are really honored to be part of your kanang learning journey. So this yeah kanang
Yes. So please guys fill out this evaluation form. Nice, Caruel. So please fill out that evaluation form no for us to know our future nga enhancements. Actually, this is our first time no in online setup. Sakto ba? Online setup no? This is our first time. Yes. So, okay guys. Wala na dyan lahat mag-on camera. Camera. You might as well open your camera. Kana. Hi, Lester.
Ate. Ang
Hi.
chat box siguro. Ito chat box.
Kanang icon nga murag message gani nya na linya sa tunga center.
Oh, wala sa ako
or maybe wala ka diri sa ano ba sa Teams wala pa ka na-add so you can't send anything maybe gasud ra ka through the link kay
Mm-mm.
so yeah I
Ay.
think that's it wala ka add sorry.
Walang di ko ka-chat ganina sa
Okay, okay. We understand. Thank you. Sa mora si Lester ay ka mga gwapo, ka mga fresh ba niya mga first years? Sana all. Hi, Camila. Hello, how are you?
Okay, ate.
Okay. Okay ra ang among pagkuan? Sabtan ra? So far, so
okay.
good?
Okay raman ta. Nindot.
Na lang.
Nindot.
Sige. Good thing no that you signed up for Metalino session because it will really help you a lot. No, thank you for that.
Could we end the kanang recording sa para
Sige, sige, sige.